So this is a class for level 2 where we cover all the concepts from 6th grade till 8th grade. So in next 1.5 years, if you guys allow me to go at the right pace, if you are able to follow me well, if you do your assignments on time, by end of this school year, you'll be pretty much all set with all the concepts that you need to know till 8th grade. And I'm not trying to push you guys to learn things faster or to get under pressure. I'm just trying to just put a disciplined effort to learn the concepts well, so that when you guys go for SAT exams in the higher grades after 2-3 years, you will just feel like, and that will be more like a breeze for you guys, if you understand the concept. So that's what we do. I don't give you guys I don't give formulas to the kids, okay? I don't say this is a formula, apply the formula and do it. No. We try to find out how is that formula derived, why that formula exists, and then we apply that. So it's more like it's a concept that we learn, and then we apply those concepts for doing the sum. Okay? Alright. So thanks again to the new kids. Welcome to the class. And who is missing here? Sunarka is, welcome Sunarka, and welcome Tanu here. But kids who are missing, first of all, request everybody to turn on your videos so that we can make eye-to-eye contact while we are learning. And let me check who is missing. I don't see Goshika. I don't see Pranav. I don't see Gitesh. Let me remind them. Dikshita is here. Sarnika is also here. So I see the 3 friends are here. Sarnika, Dikshita and Amoga. All 3 are here. Waiting for... Oh, Siddharth is also not here. For Siddharth, Devuan, Gitesh. Alright. So let's start then. So do you guys remember what we have learned so far? We have started with geometry, where we talked about the basic properties of all the different shapes, like the shapes with 3 sides, triangles, different types of triangles. We learned about the area and perimeter of the triangles. Then we went to quadrilaterals, where we learned about different types of quadrilaterals, right from rectangles to parallelograms to square to trapezium to kite to rhombus. And we derived the area and perimeter for those shapes. So today we'll talk about circle, we will talk about composite shapes. What happened? Some of you look worried. Everybody okay? Everybody okay? What is that? What is that? We are still learning 2-dimensional shapes, okay? That is part of solids. What is that? Then hold it. Hold it. We'll only learn that is important for you guys. We'll not try doing research beyond a point that gets you confused, okay? And if it comes in the part of the syllabus, we'll try learning it also. That's okay. But don't go way far from the main topic, okay? So we'll learn about the circle, we'll learn about the composite shapes today, and then if time permits, we'll switch from geometry to algebra. Okay? Alright. Any questions before we move on? No? Okay. So let's start then. And again, any shape that we learn about, the first thing we have to make sure is we understand the property of the shape. this is a circle. And again, you guys have all the freedom to laugh at my drawing skills. I'm not very good when it comes to drawing. I'll just make sure that you're able to make out what I'm drawing on the board. Okay? So this is something that you can believe to be a circle. Pretty much a circle. The property of this shape. Circle is something that we see in our surrounding every day, every minute, every hour, every second. As soon as you open your eyes itself have the eyeballs which are in circular shape. Yeah? Right. So everything that you see, even my water bottle, the base of this is a circle. Right? If you look at the fan, circle, the car's wheel, circle. Everything that you see in your surrounding is pretty much, yeah. So you find a lot of examples of circle in your surrounding. What is the property of a circle? It has a center. This is the place which is equidistant from each and every point on the border of this. So this is the center. From this point, every point on the border of this shape is same distance. So if this is, let's say, 5 centimeter, this will be 5 centimeter, this will be 5 centimeter, this will be 5 centimeter, so on and so forth. This distance from center to the border is called radius. So if you look at any circle, the key thing that you have to keep in mind is, I'm looking at something which is circular in shape, obviously. This circle, this is that. And then this is my center. And every point on the border of this shape is of the same distance from the center. And which is called radius. So center and radius, these are two basic things that you need to be aware of for us. There's no question to ask. What is there to ask?
So when you say like all the lines are just symmetry,
Not a valid question. Hold it.
what's the straight line?
What is that?
What's the straight line? That's a diamond.
So that's why I would say, I'm just starting, okay? There's a lot to cover. Let's not trigger a debate. Allow me next 10 minutes. After that, if there are some questions, we'll come to that. Okay? Otherwise, we'll end up debating, not learn anything. So, coming back to the point, every circle has a center. That center is nothing but a point which is at the same distance from every point on the border of this shape. And that distance between the center and the border is called radius. So every line that you draw from here, straight line, I'm not talking about this dancing line. Talking about any line, and every line that you draw from the center to the border of the shape will be of the same length, and that is called radius. Now, there are two things that we have learned about. Now, looking at this circle, this is the center. Now let's divide a line, draw a line which divides this circle to two equal parts. Vivan, don't do that, beta. No playing with emojis, no distractions. Next 45-50 minutes is all mine, okay? Pay attention to what I do, even if I don't look like a superstar, okay? So, any line that divides this circle into two equal parts, or a line segment that divides, that is for me to tell. Okay? So, every line that divides the circle into two equal parts, which goes to the center, is called a diameter. So, if you look at it carefully, here to here, the center to here is one radius, the center to here is second radius. So, this is called diameter. And my request to everybody here would be, I will give you guys a chance to ask questions. I will also poke you guys to tell me if there is any question. But please don't trigger a discussion. It's not a debate class, because if we start doing debate, trust me, next 1 hour will go just like this, we're learning nothing. Okay? That's why I'll be little point blank in saying what will come versus what will not. Now coming back to this point, this line divides the circle into two equal parts, and this line crosses this, goes to the center. If you look at it carefully, this line here to here is called this is called diameter, and this comprises of two radius, one radius on this side and one radius on this side. So that way you will see, or you will know, or you can relate that diameter is equal to 2 times the radius. Okay? And this diameter could be here, it could be here, it could be here. Regardless of which way you are aligning it, it is eventually dividing into two equal parts. Is everybody okay so far? Everybody with me? Okay. I have not seen Gausika yet. Okay. And Gitesh and Bhuvan. These three kids are the same. Alright. So this is just one of the properties so far. We have not looked at anything beyond this. Now so we learned what is radius, what is diameter. Now let's look at it even more carefully. So far we were looking at this being the center, this is the radius, and we said okay fine. If there are two radius together breaking the circle into two equal parts, this is called diameter. Now let's have more fun with the circle. Let's draw another line which is perpendicular to this diameter, okay, and divide this into 4 equal parts. Now this circle has been divided to 4 equal parts, where if you look at this portion, this is 90 degrees. These two lines are perpendicular to each other. This is also 90 degrees. This is also 90 degrees. This is also 90 degrees. So total angle inside a circle is 360 degrees. Okay? Or 4 right angles, whatever you call it. So these are some of the properties of the circle that you would need to keep in mind. That circle is a shape where the center of the circle is equidistant from each and every point on the border. That is one property. And this distance to the center to the border is called radius. And diameter is a straight line that divides the circle into two equal parts and goes to the center of the circle. And the total angle of the circle is 360 degrees. These are some of the properties that you would be knowing already. I'm just helping you guys recall it and relate. Now let's look at the next part of it. So when you look at a circle, now any shape that we talk about, why did I draw only this bigger circle? How about drawing a circle which is same as the size of this wall? Because that circle would have needed more space on the wall, meaning that would have needed more area on the wall. My board doesn't have that much area. So area of a shape, as you all know, is the space taken by that object on the surface. What is the area? So this is the area of this circle. So, I mean, if I go to the examination hall and somebody says, how much is the area of a circle? I will say this much. That will have no meaning. If I say this much, my teacher will give me this much. Yeah? So, there is a mathematical way to find out the area of a circle. Tell me who knows the formula for area of circle. Do you know how to dance? You have to tell. No, calm down. Tell me. Pi r square. So, if I am asking a question, you don't have to do a break dance to tell the area of a circle, okay? You have to just tell me area of circle is pi r square. Yes.
Or d pi d.
Pi d da. No, that is, no, that, okay. Keep it there. Okay, so see, the funny part is, you guys saw me doing break dance, right? Like Michael Jackson. I was asking area of a circle. The answer is pi r square. Keep your calm. That is what is needed for the maths. In the examination hall, if you come across question, you are given a radius and you have been asked to give the area of a circle. Don't jump. Keep your calm. Recall. What is the area? What is the formula for the area? Do I know what is value of r? Do I know value of pi? Do I know the value of pi? Do I know the value of r? Substitute it and you get it. Okay, that is how you have to do it. So, when it comes to math, you need speed, you need accuracy, and you need balanced frame of mind also. Otherwise, regardless of how much you know, you might go wrong. Okay? Yeah, you're saying something. No. So, I will keep stopping you guys. That is my job. I will have to keep on navigating you in the right direction so that you use your energy in the right way. It's not, I'm not making anybody feel good or bad, okay? Just trying to make sure that we use the time well and we use the energy in the right direction. Okay? Alright. So area of a circle is pi r square. Area. This is the formula. Now what is pi? Pi is a fancy term given by one of the Greek mathematicians, okay? Which is equal to 22/7. And the value of, this is a constant. This is a mathematical constant derived, given by one of the Greek mathematicians, whose value will always remain 22/7 or 3.14, whatever it is. Yes, Amoga?
Never mind.
Alright. So, and now you will tell me, why do I believe that this is the right formula? Is pi r square the right formula for area of a circle? Yeah, Dikshita.
How did 22/7 come, sir?
That was a number given. Okay. So when they were trying to find out the formula for area of a circle, they used lot of ways to derive that, and it came to a point where it was coming to r squared multiplied by 3.14 something. Okay. And they said, okay, if I have to remember this number, that will not be easy. So they came up with a universal constant called pi, whose value is 22/7. Okay? I don't know. Could be I'm saying I'm not knowing the term, but pi is, this was assigned as a, like 1 is 1, 5 is 5. Likewise, they define a constant, mathematical constant, that will be used extensively in math. Like somebody invented 0, somebody invented the numbers, somebody invented this as a constant whose value is 22/7. Defined by one of the Greek mathematician, and the way I tried deriving the formula for area of parallelogram, area of rectangle, area of trapezium, I will not try to derive the area of a circle, because this one needs lot of calculus knowledge and all, which I am not going to try teaching you guys at this point in time. If I do so, it might get overwhelming. Yeah, anybody saying something? No. Okay. Yeah? Dikshita, did I answer your question? Okay. So,
Sir, I have another question. Like, what is pi?
pi, one pi that you would know. Okay, now I'll tell you some interesting fact about it. So, you all would have eaten apple pie, banana pie, cream pie, cheese pie, whatnot, different pies, right? Pie looks like this. I like a pie called pecan pie. Yeah? Yeah, Siddharth, you're asking something, saying something?
Sir, I don't know what we're talking about. Are we talking about pie charts?
No, I'm not talking about pie chart. I'm talking about area of a circle, and the formula for area of a circle is pi r square. So the question here is, how did this pi come into picture? So I'm just trying to relate. Yeah?
What is the question? Every time when we do the area of a circle, when you said that I was universal or something, so then how many digits should we use for how many items?
So it's up to you. I have not gone beyond 3.14, and for the sake of simplicity, always use 22%. You can choose. You can find out 22/7. It can be 3.1416. It can keep on going. You can choose how much time you have, and depending on that, you can choose as many digits.
But because every digit you go will have a different answer or what you say.
So everybody knows. This will, depending on how many days you will choose, there will be different answer. Something multiplied by 3.14 versus something multiplied by 3.1416. There will be different number, obviously. But that is understood. So, okay, yeah. So, Siddharth, did I answer your question? Okay, now let's spend just 2 more minutes on this one. So, why pi? Why this term or name given as pi? Because if you all have eaten banana pie, apple pie, chicken pie or cream cheese pie or whatever pie, right? It looks like a circle actually. Since this formula was, or this constant came into existence for deriving the area of a circle, and this looked like this had lot of the emotional connection with the pie shape. That's why they give the name pi. Okay? Or else they could have given a name like chicken. Never know. Okay, alright. So let me not go into the vegetarian, non-vegetarian stuff. We'll talk here. Okay, so this is the area of a circle, and we'll not try proving why area of a circle is pi r square, because if we do so, that will be beyond the scope of this class. When you guys grow up, when I grow a little more old, after a couple of years, I will teach you guys. Okay? Alright. Now next thing is perimeter. Hold it. It's not only one person who has to learn. That's what I'm saying. When it comes to math, you need to be fast, you need to be accurate, and you need to be balanced also. So hold it. So when we talk about perimeter is nothing but the boundary of that shape. If I'm talking about perimeter of this, imagine this being my farming land, and I have to barricade it. So this is the length of the wall that I need to construct for barricading my entire land. This is the gated society. You can say it that way. This is the length of the wall. Any shape, if I have a rectangle, this is a square anyways. If I have a square, what is the perimeter? This is nothing but the total boundary. It's like I'm barricading my society. The length of the total boundary is nothing but the perimeter. If I'm talking about circle, same thing, the length, entire length. So, what is the perimeter of a circle? And I would not want the answer to come from Arabic, Arab. I would want to hear it from the screen. Anybody remembers area of a perimeter of a circle? No, hands down. Let everybody participate. Anybody remembers the perimeter of a circle? Yes, Sunarka?
2 pi r.
2 pi r. So that is the perimeter of a circle. So like what Advik was saying, we can say pi into d, pi into diameter. So 2 times the radius, meaning the line that divides the circle into 2 parts. This is called diameter. So 2 times the radius, this radius plus this radius. 2 times the radius becomes diameter. So that's why we can say 2 pi r or pi into d. This is the perimeter of a circle. These are the things that we wanted to learn about when it comes to area of a circle or perimeter of a circle. Any questions so far? And these questions will be pretty straightforward. Okay? When we deal with them, right now when I'm teaching the kids who are doing SAT preparation from, yeah, circumference. Yeah. You can call circumference. That's it. Yep. Yes, Dikshita, tell me.
What is pi, sir, and how do you operate it?
So pi, like if you ask me what is 3, 3 is a 3. Likewise, pi is also a derived constant. Okay, it's a named constant, pi, and value of pi is 22 divided by 7. Okay. So now if you say 22 divided by 7, you can find it out how much it will be, right? 22 by 7 will be something like 3.1416 or something, okay? I'm not going to do that thing right now if you want me to, unless you want me to. Yeah, Mugra.
So I usually just use 3.14.
You can use 3.14, that should be enough. Okay? Because, I mean, you can do rounding and estimation to use the nearest number. I mean, if you are in a hurry, you can do multiply by 3 and you can still move on. If you have to get the approximate value. But yeah. But otherwise, this is the exact value, and you can figure it out based on that. So here, in case of circle, area of circle or perimeter of circle, you will use this formula and you just need to know the radius. That's more than enough. That's the only property that you need to be aware of. If you know the radius, you can find out perimeter, you can find out area and whatnot. And when we do few sums, obviously you will be able to apply that and you will be able to use that for solving the problem. Okay. Now, whatever we have learned so far, these are all called two-dimensional shapes. Meaning, you are seeing it on the surface. It has length and width, no height. So be it rectangle, be it a square, be it trapezium, be it rhombus, whatever we have learned so far, these are all two-dimensional shapes. It has length and width, meaning horizontal and vertical. There is no third dimension where it includes height. So when we, maybe after we touch upon a bit of algebra, and when we come back to geometry again, we'll learn about the solid shape. That is when we'll talk about the shape which has height to it, and then whatever we are talking with respect to area, that transpires into volume. So just giving you guys some glimpse of it. When you look at a rectangle, this is a rectangle, you add height to it, this will become a solid shape called cuboid. So here we'll talk about the volume of the cuboid and the surface area. So in case of a shape we talk about area, here we'll talk about the volume. So it's like, imagine this eraser, right? It has this rectangle. Now if you look at this has height also, meaning we have put rectangle after rectangle after rectangle after rectangle, multiple layers is what has led to the height, and that is what has made it a solid shape. So here you have a rectangle and you have added a height. That's how it has become, area has converted into volume. Okay, so area, multiple areas put one after another, converts into height. So you will, whatever we learn here as a rectangle, that will convert into a cuboid. We are not learning that right now. Maybe after a month we'll come back to this and we'll talk about the solid shapes. Yeah, Dikshita, you're asking something.
I raised it by accident.
Okay, that's fine. Similarly, we'll learn about square. We add height to it, same as the length and width, and it will become a cube. That will be the three-dimensional shape that we'll talk about. Same thing. We will not talk about area, we'll talk about volume and surface area. Surface area is the outside of it, and volume is the total space that it takes in a three-dimensional space. Similarly, we learned about the circle right now. We'll talk about cylinder, meaning circle after circle, they stack one after another. That is what will form the cylinder. We'll talk about the surface area and volume for this also. Similarly, we'll talk about more interesting stuff called cone.
What can I screen call? Upside down.
Either way. Yeah.
We're gonna go triangle, segment, or pyramid.
So we'll see. We'll come to that one by one. So I started talking about alphabets. I was at C, and you are asking me what about S, T, and U and V. So hold it. Allow me to go in a flow, and then if there is something that we are missing, we'll come back to that. Another thing, we learned about circle. Now imagine this circle being rotated, against an axis here, and that becomes like a ball. That ball is nothing but a sphere. We'll talk about the volume and surface area of a sphere also. Yes, Dikshita.
What is the difference between the cuboid and a cube.
If you imagine a rectangle or, okay, just give me a second. What does this look like? Like a rectangle? A4 sheet? So what I'm doing here is, I am putting A4 sheet after A4 sheet after A4 sheet, and that is what is adding height to it, right? So whatever was my rectangle, that became a cuboid, okay? I added height to it, it became a cuboid. A cube is nothing but, I had a square. Imagine this being a square. And then I added same side square after square after square and added to a height where my length and width is already same because square has all sides same. I added to an extent where the height is also same as my length and width. Okay? So the way you can relate, if you guys have played snakes and ladders, you use dice, right? You throw it and you get a number. It is a perfect cube. I'm talking about the dice that you throw. It has 6 sides with numbers written imprinted on the each side from 1 to 6. That is a cube. Where if you look at the dice on each side, you will see a square. Each side. Okay? Or the ice cube in the fridge. I mean, though nowadays we get fancy ice cubes because the frames are different. But in actual terms, on the most authentic way, the ice cubes are the ice cube which is 1 centimeter in length, width and height. That is what is a perfect ice cube. Okay? So that's the difference between a cube and a cuboid. If you want to put one line, you will say a rectangle converts into a cuboid, a square converts into a cube. Okay? That is how you can relate it. Make sense? Yeah?
Yes, sir.
Alright. Now, so we are just trying to see how things relate here. Whatever rectangle I have learned here, that will convert to cuboid and we will talk about the volume and surface area. My square converts to a cube, we will talk about the volume and surface area. Not right now, maybe after 3-4 weeks, once we come back to geometry again. My circle converts into a right cylinder. And if you look at this carefully, it is nothing but actually a triangle which I am rotating against this axis, and that becomes a cone. Okay? Similarly, this circle, when I rotate this around this axis, it becomes a sphere or a ball that we see, or even earth for that matter. So these are the 3-dimensional objects that we'll talk about. Similarly, you can always think of a prism made out of triangle. This is my triangle. I protrude this in, like the Mars chocolates, right? The triangular ones. So there are different shapes, but every 3-dimensional object that we talk about originates from a basic 2-dimensional shape. When you add height to it, that is when it converts into a 3-dimensional shape. Okay? And why we say 3 dimension? It's because of this. So far, you can draw a rectangle or triangle or thing along x-axis and y-axis. Now when you add a z-axis, a z-axis, to add height to it. What is that? I have not seen 4D in my life so far. I'll wait for that. Okay? So, but mathematically you will not need. Okay? People talk about 4D, 7D, all those fancy stuff. But for the sake of mathematics, as long as we know 2 dimension and 3 dimension, that will be more than enough. Okay? Let's not overwhelm ourselves by going into too much of complexities, because whatever we are learning here, our purpose is to make things simpler, not to make things complicated. If you make things simpler, it gets interesting. Alright? So that's why when I am saying 3 dimensions, I am talking about shape which has length, width and then height also. Okay? So that's why it's called 3 dimensional. So x, y and z axis or z axis. That's why it's called 3-dimensional objects or solid shapes. Are you guys okay with whatever we have discussed so far? Any questions? No questions? Snarka? So far okay for you?
Yeah, good.
Okay. Alright. Now let's look at something funny. Whatever we have learned about triangles, we have learned about quadrilaterals.
Hexagon.
Don't jump to conclusions. Give me some time. So we have learned the basic shapes. We have learned about parallelograms. What not? This shape is not something that we have seen. At least I cannot give it a name. I mean, okay, I can count the number of sides and then give it a name. Based on 7 sides, I will say heptagon. 8 sides, I will say octagon, whatnot. But then, still, there is no standard formula I have. These are called composite shapes, meaning shapes which are made by joining multiple shapes together. Now look at this. Somebody says find out the area of this guy. So if somebody says find out the area of this guy, you will not have any formula to find out the area of this. Because there is no formula that exists actually. What is that? Yeah. But no, so okay, let me complete on the board, and if there is a question, I'll come back to you. Perimeter we can do. Perimeter we can do for any shape. So here, so see, conceptually, if you are talking about any shape which is not a basic shape, we call it a composite shape, which is made of by joining multiple shapes together. If you have to find out the area of this, your first attempt has to be just break it down. Join the vertex and see how you can. Now if you look at this shape, this is one triangle, this is another triangle, this is another triangle, this is probably a trapezium, and this is another triangle. If I know the sides, all these sides, I will find out the individual areas of these small simpler shapes and add them together. That will become my area. So doesn't matter. So basically composite shapes, if you come across any questions that you have to solve for a composite shape, if you look at any shape like this, don't start panicking or start worrying. Your first attempt should be, okay, is this one of the common shapes that I am aware of, where I know a straight formula? If I do, wonderful. If I don't, what will I do? I will just join the vertex or the corners and see if I am able to break it down into simpler shapes. If I can convert this into simpler shapes, I'll just add the area of the simpler shapes together, and that will become my final area for the shape that I am calling as a composite shape. Okay, so that's the only thing that we wanted to learn about the composite shape. Any questions about this one? You will find questions around composite shapes. I'll give you guys some assignment on this one also. But net, it comes down to how you are breaking this into simpler shapes and finding the area for simpler shapes and adding them together. That is all about the composite shape. It sounds a little complicated, but when it comes to solving it, it is no different from what we have learned so far. Any questions? No?
No, sir.
No? Okay. Pranav, you joined a little late today, but you'll have no choice but to watch the video offline and let me know if you have any questions. Okay? So whoever joins late, you will certainly have a chance to and once I upload the video of the class, you can watch the video and just go through it, note down the points that I mentioned. If there is something that is not clear, just let me know. I will try explaining it. Alright? So just a quick recap of what all we have learned with respect to geometry so far. We talked about line, segment and rays. Then we learned the angles, different types of angles, acute angle, obtuse angle and right angle. Then we learned about the triangles and the properties of triangles, where we talked about triangles classification based on angles, where we talked about acute angle triangle, right angle triangle and obtuse angle triangle. Then we talked about classification of triangles based on sides. When all sides are same, we call it equilateral triangle. When two sides are same, that is called isosceles triangle. And when all the sides are different, that is called scalene triangle. And then we learned about how to find out the area of the triangles. And then after that, we learned a lot of concepts around the congruence, meaning how to make how do we find that the two triangles are same. That is when we learn about the 4 theorems of congruence: SSS, ASA, SAS and RHS. These are the 4 theorems for congruence that we learned. And again, those are there in the video. If any of you forget or start wondering about what I'm talking about, you can watch some of the previous videos and that should clear the rest. And then we came to learning the properties of quadrilaterals. That is where we learned about rectangles, squares, parallelograms, rhombus, kite, trapezium, their properties. And then we learned how to derive the formula for the area for these shapes. That I will give you guys in the assignment. That is what will come in the assignment of homework. What is that? No, that everybody has to show the assignment to their parents and explain to them, say, okay, this is what the question was, this is what I have done. And if you are able to explain it, that completes your assignment. I keep checking with the parents, say, okay, are the kids explaining the assignment to you? So please show it to the parents, because if I start checking homework in the class, I will only check homework. I will not be able to teach anything. Okay? Yeah, Muga.
My mom was wondering if you can check it too, because sometimes my parents want me wrong with the answers.
For some cases, okay, I can randomly check for some of you. That's okay. But I'll not check for each and every kid. What I can do is, see, the reason why I'm asking the kids to show the assignment to the parents is because when you explain to them, right, that is when you also would know whether you are clear about what you have learned or not. If you are fumbling, if you are struggling to explain, that's a clear red flag. That clearly shows that either I did not teach well or you did not grasp well. Yeah. So that's the reason why I am asking the kids to show the assignments to the parents and explain. So that's the purpose of it. But on exception for 1 or 2 kids, I can check. But I would not want to make that as a practice where I end up checking assignment for each and every one of you, because that way your parents will never get the confidence. You will never be able to make out whether you have learned something enough to be able to explain to somebody or not. Yes. Yeah, Vivan.
Sir, after I like show it and explain it to my parents, do I have to
You have to send it to me anyways. You guys are send it to me any which way, right? So I keep getting the assignments from the kids in the WhatsApp, but I'm not checking for all of you. Okay, for some of you I just randomly pick up some samples and check, but I'm not making that as a practice to check each one of your assignments, because then the whole purpose of the methodology of how we are learning, that gets diluted. Okay, if I start checking for each one of you, we'll end up making compromise, trust me, with respect to the way we are learning things here. Okay? And even there has been days when I come to a class to teach some concept to one of the kids, you guys, and then I start fumbling at times. If I have not understood the concept, if I have not read it, if I have not practiced things well, I end up fumbling. So that's a reflection of whether I'm clear about the concept or not. So that's what I'm enforcing here, and that's why I'm asking you all to do your assignment and show it to your parents as if you're teaching your parents. Say, okay, this was the sum. Yeah.
When will we get home?
So we do class on Saturday and Sunday, and I upload a video of the class latest by Monday evening, and by Tuesday I send the assignment, the WhatsApp group, okay, where your parents are added. Really, I'm not using anymore because most of the kids are on WhatsApp and my WhatsApp has started working. So yeah.
Those people you mentioned that we have to start up and do it like that.
What is that?
Those have to start up.
Sign is not the thing, okay? It's not a government office where you have to get a signature to get your salary. It's an exercise that we are doing week on week. So if I'm spending 2 hours to teach you guys, if you guys spending 45 minutes, 1 hour to do the assignment, I'm asking you to spend 10 minutes more. You don't have to walk your parents through each and every assignment, each and every question. You can say, okay, let me walk you through 3 of the questions that I've solved. So when you teach that, when you explain to your parents as if you are teaching him or her, say, okay, this was the question, this was the topic that I had learned, this is the formula that I learned, this is how I figured out how to derive the formula, and now I'll show you what did I do for this question. This question says this, here's the information I had, this is how I have solved it. When you are able to say that much of a story, you will be confident of yourself that yes, I have understood what I learned. And your parents will also be able to sense. Right? It's like watching a good movie versus a bad movie. If you watch a good movie, the movie keeps you connected from beginning to end. Right? You enjoy each and every part of it. You see that somebody has done a very good acting. The content was very good. So, I'm not going to the detail of the movie, but the concept part of it. If you watch a bad movie, within 5 minutes you'll make out that okay, do I really want to spend my 3 hours watching this crap, or is it worth watching 3 hours? Right? So that is the purpose. So when you start explaining to your parents can understand whether you have understood it or not. Are you confident or you are fumbling? Same way, you will also know that when I am explaining to somebody, am I sounding confident or I'm just blabbering?